Today we are going to be dealing with equations and fractions, but ones that need to be solved by multiplication. And specifically multiplication, not division. Why am I saying that? Well, think about what we've just gone through in the previous section when we were just doing fraction operations. At no point did we actually use division. If we were presented a division problem, we solved it with multiplication. So I'm going to do my best to show you guys how to immediately treat these as multiplication problems to solve. Step one is still going to be convert any improper or mixed numbers to improper fractions. We know we can't use mixed numbers with multiplication, so let's just get to improper fractions. So for number 9, 2 times 3 is 6, plus 1 is 7, so we have negative 7 halves, n, equals 3 times 4 is 12, 12 plus 2 is 14, negative 14 thirds. Now, when you look at this, you are inclined to think, okay, negative 7 halves sitting in front of n with nothing in between. That means it's multiplied to n. So I have to divide to solve. Your logic here is sound. It makes sense. But we know we can't actually divide fractions. Now, when we were doing fraction division, I taught you the idea of keep, flip, change. Fancy little acronym just to help you remember the process. But what we're really doing is called multiplying by the reciprocal. Instead of dividing by, in this case, negative 7 halves, we're going to multiply both sides by the reciprocal of negative 7 halves. And what's a reciprocal? The flip of a fraction. It's a fancy word, fancy math word for flip. So instead of trying to divide both sides by negative 7 halves, which we know we cannot do, we're going to multiply both sides by negative 7 halves. Sorry, negative 2 sevenths. Flip that fraction, negative 2 sevenths. Now here's why. I've got fractions being multiplied on both sides. On the left side, look, the 2's cancel out, the 7's cancel out, and negative times negative is positive. So we're left with a positive n. That's what we want. We want n by itself. On the right-hand side, pay attention, we have a 14 and a 7 diagonal from each other. We can simplify those into a 2 and a 1. So now we can just multiply straight across. Negative 2 times negative 2 is positive 4. In the denominator, 3 times 1 is 3. That's improper, so we do need to adjust it into a mixed number of 1 and 1/3. All today is going to be is doing this process. Figuring out the fractions on each side, and then multiplying by the flip, or the reciprocal, of whatever is with the variable. Now take a look at number 10. Right now, it doesn't look too bad. There are no mixed numbers to convert, but our variable is sitting in the numerator of a fraction instead of sitting beside it. That doesn't actually matter. And here's why. If I take that variable out of the numerator and just sit it beside the fraction, I've not actually changed the value there. 3 times m divided by 5 is the same thing as 3 divided by 5 times m. All I've done is pull the m out of the fraction so that it's a little easier to see the fraction as a fraction and not this weird thing that has a letter inside of it. Please know this is only something that can be done when the variable is in the numerator of the fraction and is multiplied to whatever number is in the numerator of the fraction. Okay, this is not a trick that you can always just take the variable straight out of the fraction. Very specific circumstances. It must be in the numerator. It must be multiplied to the number in the numerator. Now, the process we're doing today, once we have fraction, variable equals fraction, we're going to multiply both sides by the reciprocal of the fraction with the variable. 3/5 is with the variable, so we're going to multiply both sides by 5/3. And the reason for that is if we do it correctly, we should be able to look on the side that has the variable, which is our left side here, and say, okay, I've got 5's diagonal, they cancel. I have 3's diagonal, they cancel, leaving just the m. On the right side, now we do have a lot of simplifying here. 33 and 3 can divide by 3 to become 11 and 1 respectively. 25 and 5 can divide by 5 to become 5 and 1 respectively. In our numerator then, we have 11 times 1, which is 11. In our denominator, we have 5 times 1, that is 5. That's improper, so it cannot be our final answer. 11/5 is the same as 2 and 1/5. At this point, I invite you to pause and try numbers 11 and 12. Number 11 needs us to pull the n out of our fraction. And then we're going to multiply both sides of our equation by the reciprocal of the 7/16 that's attached to n. The reciprocal is 16/7. On our left side with n, we can cancel the 16s, we can cancel the 7s, so that only the n remains. On the right side, we can cancel the 7s. They technically become 1s. And 24 and 16 can actually simplify and become 3 and 2, respectively. They are both divisible by 8. Now, something to be careful of, and I wasn't, the negative sign, which I'm about to erase, kind of blended into my fraction. Don't want to let that happen. You want to make sure if there's a negative sign that you see it clearly. So now let's multiply. In our numerator, we have -1 times 2. That's -2. In our denominator, 3 times 1. That's 3. That is a perfectly acceptable fraction. Finally, in number 12, we need to convert the mixed number of -4 and 1/6 into -25/6. 6 times 4 is 24, plus 1 to make my 25. Now I'm going to multiply both sides by the reciprocal of the 10/3. That's with x. So I'm going to multiply both sides by 3/10. On the x side, everybody except for x will cancel out. On the number side, we've got some simplifying to do. 25 and 10 can both divide by 5. 3 and 6 can both divide by 3. So in our numerator, we have -5 times 1, that's -5. In our denominator, we have 2 times 2, which is 4. That's improper, so we do need to convert it back to its mixed form of -1 and 1/4.